This is the fourth section of chapter 4 on graphs and transformations, and this section is about points of intersection. So to find the point of intersection between two graphs, we need to use the equations of the graphs to form and solve a simultaneous equation. So for example, if the equation of one of the graphs is f of x and the other is g of x, then the point of intersection is the solution to f of x equals g of x. Now, when we solve this here, this will give us the x coordinate, so solution will give x coordinate. What we then need to do is to substitute that x coordinate back into either f of x or g of x to find the y coordinate. So I'll just put down here sub into either f of x or g of x, or both if you want to be doubly sure to find the y coordinate, because for a point of intersection you need the x and y coordinate, or the x and y values. Example 6, on the same diagram, sketch these curves here, and then in part B we're going to find the coordinates of the points of intersection. Okay, so we'll need to sketch these, so it's not about plotting them. So the first equation we've got, I can see that that's a quadratic, so I want to know where the roots are, where it crosses the y-axis and where it crosses the x-axis. Okay, so let's make x equal to 0 and find out what y is. So when x equals 0, I'll have 0 here. So anything times 0 is going to be 0. So y equals 0. So I know that's going to be one coordinate. And also I want to find out when y is 0, or make y equal to 0. And that will happen when either x is 0 or when x is 3. So the 0, 0 gives me the coordinate I've already got, and the other coordinate will be 3, 0. So that means I want to draw a U-shaped quadratic because the coefficient of the x squared is positive, going through the points 0, 0 and 3, 0. So let me just mark those two points. So 0, 0, and we'll probably put 3, 0 around that type of point there. And let's draw this. So this will be my quadratic. Just a sketch like that, and we'll mark this as the number 3 here, and we know that's the origin there, and then we'll label up the graph here as y equals x minus 3. Right, okay, so let's now look at the other equation, which is the x squared 1 minus x. So I'll just do the working for that here. Y equals x squared 1 minus x. Now this is a cubic, because if you multiply it, you're going to get x cubed. Now when I multiply it out, I'm going to get a negative x cubed. So that means the shape of my graph is going to be one of these cubics that goes down. Just like before, I need to work out where this graph is going to cross the y-axis and the x-axis. So we'll start with x equals 0. So when x equals 0, then I'm just going to get 0 here. So it doesn't matter what I multiply it by, I get y equals 0. So that gives the coordinate 0, 0. And I'll make y equals 0 and find out what values of x are going to make y equal to 0. So I'll just write 0 equals x squared times by 1 minus x. So just like before, when x is 0, y will be 0. So it's going to be one of the solutions, x equals to 0. And then I want the other solution is going to be when 1 minus x equals 0, which gives me a value of x equal to 1. So one coordinate is going to be 0, 0, which I've already the other coordinate is going to be 1, 0. So we'll just put that down, 1, 0 here. So we'll plot those points. The 0, 0 we've got already, and the 1, 0 we'll plot here. So we know we're going to have a cubic that needs to sort of go this shape. Now remember, when it's squared, this will be where it bounces. So this 0, 0 is going to be where the cubic bounces off the axis here, and this is where it's going to jump. So I'm just going to trace out what it's going to look like. So down there, up, bouncing off there, but cutting through that point. If we try to make it cut through that point, we're not going to be able to get the cubic shape. It's going to end up like a quadratic, so it's got to bounce here and then it will cut through here. Now in terms of the steepness, an x cubed graph is going to be steeper than an x squared, so it's going to be steeper at this end, so it's going to cut around here, bounce here, and then go down, and then it sort of goes down, and it's going to sort of only crossing that one point, so the steepness doesn't matter. But here it's important we get the steepness right to show that it's going to cut that. Yeah, we're not going to get a cubic that goes like this, going to cut at some point there. Right, so let's draw that now, that cubic. So we're going to have something like this, bouncing there, cutting there, and then we've got that type of shape. Right, part B, find the coordinates of the point of intersection. So let's label this first. Y equals x squared times by 1 minus x. So to find the points of intersection, what I need to do is to make x times x minus 3 equal to x squared times by 1 minus x. Now I can see from my sketch that there are 2 points of intersection, so let me just highlight them. So that tells me something about the number of solutions I should get from this, and also maybe the signs. So over this way I'm expecting x to be positive and y to be negative. Over here, x to be negative and y to be positive. So I've got some sort of idea of what type of solutions I should be getting. Right, so we'll start by expanding the brackets. So I'll have x squared minus 3x equals x squared minus x cubed. We'll bring everything to one side. So we'll add x cubed to both sides. We will take away x squared from both sides, so there's no x squared. And then we've just got minus 3x equals 0. Now from there, what we want to do to solve this, we need to factorize it. So we can take an x outside the bracket, and then we'll have x squared minus 3 equals 0. Now the solutions from this, I'm going to get x equal to 0. Then the other solution will be when x squared minus 3 equals 0. So let's go and solve that. So that will be x squared equals 3. Then we need to remember that we have a positive and negative square root. So that means that x is going to be equal to plus or minus root 3. So we now need to find out what the y coordinates are, because it's only part of the solution. So let's choose the one where x equals 0. Now that's going to be this point here, isn't it, the origin, but I still want to solve it to be sure. So when x equals 0, I'm going to substitute it into, now I've got a choice, either one of the two equations, this one here or this one here. I'm just going to pick the easiest one. That looks easy enough. So y is going to equal 0, and I know this already, times by 0 minus 3, which means that y is 0. So that gives a point of intersection as 0, 0. So I'll just highlight that. Now we'll go on to using x equals positive root 3. And again, we'll put it into this equation here. It doesn't matter which one. I'm going to use the one that looks easy. So y equals root 3, positive root 3, times by root 3 minus 3. So multiplying the brackets, that will give us y equals 3, root 3 times root 3 is 3, minus 3 root 3. So that gives us this coordinate. When x is positive root 3, y is 3 minus 3 root 3. Now what have we got here? We've got a positive x coordinate, and this number here is going to be negative because 3 root 3 is bigger than 3. So positive x, negative y, that's what we expect. So it's probably this point here. So we'll highlight that. So the last thing we need to do is just to substitute in x equal to negative root 3. So when we do that, we'll get y equals negative root 3 times by negative root 3 minus 3. We'll expand the brackets, and negative root 3 times by negative root 3 is just going to be positive 3. And then negative root 3 times by negative 3 is going to be plus 3 root 3. So that gives our final coordinate as negative root 3, 3 plus 3 root 3. We'll just highlight that. Now that must be the other coordinate. Can you see the x value is negative, which is what we're expecting, and the y value is positive. So that gives me an indication that I've probably got these right. My sketch is going to help me decide about the signs of the solutions and whether I've got the right signs or not. Example 7. On the same diagram, sketch the curves with these equations where a and b are positive constants. Now you'll notice on this question we've got letters here. So when we write down maybe the coordinates where this graph or this graph intersect across the axis or touch the axis, we may need to give those coordinates in terms of a or b. So we'll start with the first one. So y equals x squared times by 3x minus a. So I can see this is a cubic, and it's a cubic where the coefficient of the x cubed is going to be positive. So I'm expecting a cubic to get this type of shape. So let's start by making x equal to 0. So if we make x equal to 0, this is 0, so it doesn't matter what this is. Anything times by 0 is 0, so y equals 0. So that gives us the coordinate 0, 0. And then we're going to make y equal to 0 and solve that. So if we make y equals to 0, we'll have 0 equals x squared times by 3x minus a. So what does this mean? Okay, so it either means that x squared equals 0, which means that x equals 0, or it means that 3x minus a equals 0. Now if we rearrange that, that means 3x equals a, x equals a over 3. X equals a over 3, a divided by 3. So this gives us the other point of intersection, which is going to be a over 3, 0. So we'll just highlight those coordinates for now, because we'll need them in a minute. And then we'll go on to the second equation, which is y equals b over x. Now this is a reciprocal graph where this number is positive. Notice in the question it says that a and b, and this is important, are positive constants. So since this is going to be positive and it's reciprocal graph, it's going to be this type of shape, like this. Okay, so now we're ready to sketch our curves or graphs. So we'll start with the cubic. Now notice that the x squared gave us the x equals 0. So this is where the cubic will bounce. So it's going to bounce off that coordinate. So let's mark the coordinates in 0, 0 and a over 3, 0. Now a is positive, so this is positive. So it means it's an x coordinate over here somewhere. We don't know where. So I'm just going to mark it here like this and call that coordinate a over 3. So my cubic is going to be one that goes up like this, bouncing off of there, and then going through that coordinate. So it's going to be that type of shape. So let's put that in. So going up like this, bouncing there, and then going back up through that point, and we'll label that as the y equals x squared times by 3x minus a graph. Now we'll do our reciprocal graph. So that's going to be like round here and round here, and like this. So I'll put that in. And so we're going to have a graph like that, and the other part down here like that, and we'll just label that up as our y equals b over a, or b over x. Now part B, state, given a reason, the number of real solutions to this equation here. Okay, so you might look at this and think, well, what's this got to do with this equation here? Well, actually this is this part, and this is that part here. So let's write that down first. X squared 3x minus a minus b over x. Now, if I add b over x to both sides, I'll have x squared 3x minus a equals b over x. Now, what have I just done? I've made this equation of this curve equal to this equation. So this represents the number or the points of intersection of these two curves here. So we'll just write this down. Okay, so we've put that down. So we can see from our graph that there are only 2 points of intersection. You see one here and one here. So that means that this equation here has only got 2 real solutions. So we'll write that down. So our sketch shows that these curves intersect at 2 points, ones we've highlighted in green. So the equation x squared times by 3x minus a minus b over x equals 0 only has 2 real solutions, because we can see there are only 2 points of intersection. Example 8. Sketch, or in part A, sketch the curves y equals 4 over x squared and x squared times by x minus 3 on the same axis. Right, so let's start with the y equals 4 over x squared. Now, hopefully you should remember that the shape of this graph is one of these reciprocals. So it's going to look something like that. So we'll sketch that in a moment. Then for the other equation, y equals x squared x minus 3. Okay, this is a cubic. Its coefficient of x cubed is positive, so it's going to be a cubic that goes like this. So it's got that type of shape to it. So let's start by making x equal to 0. And if we make x equal to 0, it means that y equals 0. So that gives us the coordinate 0, 0. And then we'll make y equal to 0, which means we'll have 0 equals x squared times by x minus 3. This either means that x squared equals 0, which means that x equals 0, which gives us the point 0, 0, which we've got already, or it means that x minus 3 equals 0, which means that x equals 3. So this gives us the other coordinate, which is going to be 3, 0. So because this coordinate, the 0, 0, comes from the x squared, because this will give us 0, 0, let's put it down here. This means that the cubic is going to bounce off of 0, 0. So let's draw a sketch. Okay, so we will start with the cubic graph. So we'll start with this one, and we'll just draw a sketch like this. So it's going to be this type of shape. So it's got these asymptotes on the x and the y axis, that type of shape. Then for the cubic, we're going to plot the coordinates. So we've got 0, 0 and 3, 0. So 0, 0 and 3, 0. So we'll just mark that as 3. And we know it's going to be a cubic that sort of goes up like this. it's going to bounce off of the 0, 0 and then cut through the 3, 0. So let's mark that in. So I'll have a cubic that looks something like that, and we'll just label our graphs y equals 4 over x squared and y equals x squared times by x minus 3. Now part B, using your sketch, state with reason the number of real solutions to this equation here. Now again, you might look at that and think, what's that got to do with what we've just plotted? But if we make these equal to each other, they can be rearranged to give us this. Okay, so in part B, let's start by what we've been given, which is this. X to the power 4 times by x minus 3 minus 4 equals 0. And what I'm trying to do is to get this on one side and this on the other. So first thing I'm going to do is to add 4 to both sides. So x to the power 4 times by x minus 3 equals 4. Then divide both sides by x squared. So that will give me x squared times by x minus 3 equals 4 over x squared. Okay, so this represents the point of intersection of those two graphs. Okay, so this represents the point of intersection, points of intersection of the graphs or curves x squared times by x minus 3 and 4 over x squared. So we can finish this off by saying that since our sketch shows just one point of intersection, and that's this point of intersection here, whoops, let's highlight it rather than draw over it, point of intersection here, the equation, this equation here, which we rearranged, only has one real solution. For every point of intersection, that represents a solution to this equation. We've only got one point of intersection. You should now be able to do exercise 4D on pages 69 to 71.